Good morning. This lesson begins a series of lessons on the wonderful topic of factoring, which is kind of the bugaboo for a lot of Algebra 2 students and Algebra students and Pre-Cal students and math students in general. So we're going to take it really nice and slow, and we have a great activity plan that goes with this that I hope is going to work, but we need to kind of set the stage for the activity and make sure that we are squared away on what our vocabulary is. And how to break things down. So this first part of the lesson is going to cover the vocabulary and cover some basic examples of factoring. So the first question we're going to ask is, what are factors? So I'm going to give you a definition for what factors are. They are expressions, and that is an older math word, but expressions, we'll do a little definition of that. They are expressions meaning numbers or variables, okay, so numbers or letters that are multiplied. And that's the key thing there, is that factors are numbers or letters that are multiplied. So when you have things that are multiplied together, those things are factors, and the result of the multiplication is what's called a product. Not as interested in the word product right now, but we do want to make sure we're clear on what factors are. And that leads us to the second question, which is, what is factoring? If you look up here where we have the lesson title, Factoring 1, there's going to be 3 factorings and then a factoring of 4, which is kind of the recap day. What is factoring? Factoring is a little bit of a circular definition here, and it's why we have to make sure we define what factors are first. But the process of factoring is breaking an expression, which again, of course, is numbers or letters, breaking an expression into its individual factors. In other words, factoring is the process of figuring out what things were multiplied to give you the expression that you have. Now, it's very closely related to division. So I don't know what I'm writing there. Let's try that again. Closely related to division. And in fact, sometimes you will actually use division in your factoring. And so you'll use division to figure out what the factors are. Usually in division, you're given one of the factors, and then you use division to find the other factor, where factoring by itself is more like out of the blue. So you just have to figure out what was multiplied to give me what I have right here. Now, if I were to ask you what's the opposite operation or the inverse operation of multiplication, you could answer division, which is what most of you would say, but you could also say factoring. Factoring is going in the other direction. So I'm going to give you some examples, and we're going to progressively get to like more complicated examples so you can see what we're driving at here. So these are going to be examples of what's called prime factorization. Factorization. And prime numbers, I guess prime numbers are things that are that can only be divided by like 1 in themselves. When we're talking about prime factorization, what we mean is we factor it as much as we can. We cannot split it up into any smaller things that are multiplied. So let's look at the first one. We're going to do the first one. If I were to ask you what 2 numbers multiply to give you 12, so you're going to break 12 up into its factors. Well, some of you might say 2 times 6, and you would be right. Now, when we talk about prime factorization, we mean like, can we break it down any further? And if you look at the 6, you can actually break the 6 down, like what 2 numbers multiply to give you 6? Well, that would be 2 and 3. And then, of course, the first 2 would still be there. And we would call this down here, the 2 times 2 times 3, the prime factorization of 12. Now, just to see why that's important, some of you might have said, oh, well, you could factor 12 into 4 times 3, which would also be correct. And usually when I ask this question in class, I'll get both answers. Like some of you will think 2 times 6 and others of you will think 4 times 3. Now, this would be a bona fide different factorization. But if I look at the 4 times 3 and I ask myself, can I break this down anymore? You'll look at the 4 and realize that the 4 breaks down into 2 times 2, and then of course the 3 is still there. Now, the key thing about prime factorization is that it's always the same. There's many different ways that you could factor a number, say like the number 24, but there's only one prime factorization. So if I ask you to factor something, usually what I mean is the prime factorization, because then everybody in the class is going to get the same answer. So if I say just factor a 12, I could get half of you saying 2 times 6 and half of you saying 4 times 3. But if I say give me the prime factorization of 12, all of you should come down to 2 2s and a 3. Now you might have them in a different order, okay? But remember that multiplication is commutative, meaning you can switch the order of your multiplication and ultimately they would all be the same. All right, let's look at another example. What if we had 6x squared? So you can like recognize that that's multiplication there. So this would break into 6 times x squared. And 6 could break into 2 times 3, and x would break into x times x. Usually we don't factor like that. We're going to do it in today's class, maybe like spilling into tomorrow's class, for the purpose of finding a GCF, but typically we would not factor like a 6x squared out, although you want to be mindful that there are factors there. And the last example that I have is this. It's like 4x squared y to the third. And this, I broke it down like 3 ways into 4 times x squared times y to the third, because that's all that means. That's all implied multiplication. And then the 4 can break into 2 times 2, and the x squared is x times x. And then the y to the third breaks into y times y times y. Okay. That's as good as it's going to get down there. Y times y times y. And again, this is called the prime factorization. It's this idea of figuring out what was multiplied. So we want to go back to those definitions. Factoring is breaking an expression down into the individual factors, which are the expressions, could be numbers, could be variables, that are multiplied to give you that. And so if you have something like 6x squared, you could break it down into the expressions that multiplied give you 6x squared, which is 2 times 3 times x times x. Now, the reason... let me put this here, clear that out, and put this little note in here. Factoring undoes, I'll put that in quotation marks, undoes multiplication. And that's where we get that idea of, that is horribly written. Let's DOES, there we go, undoes multiplication. You get the idea that factoring and division are very closely related, because you could say they both undo multiplication. And the reason I spend some time on this is because we toss out like the directions, like you might have directions that say factor this. And if you're not clear on what factoring means and what you're being asked to produce, then you kind of get stuck at the problem in the beginning. So next thing I'm going to do is give like a multiplication problem and a factoring problem so that you can see how those are related to each other. So we have on the left-hand side a multiplication problem, and on the right-hand side we'll have a factoring problem. So our problem is going to look like this: 3 times x plus 4. And you should recognize that as being multiplication. That's distribution, and distribution is just a specific kind of multiplication. Distribution is multiplication over addition or subtraction. And when we say over, we mean like through the parentheses. So we multiply the 3 times the x and the 3 times the 4, and we get 3x plus 12. And we would call that distribution, but it's multiplication. A factoring problem would go in the opposite direction. So you would start with the 3x plus 12, and then you'd ask yourself, what 2 things got multiplied together to give me that? And so you would look, and hopefully you'd recognize that that would be the 3 and you would do this. Now I want to point out a couple things. First of all, these are the two things being multiplied. So the factors would be 3 and I'm going to keep this in parentheses. You don't really need to have it in parentheses there, but the factors are 3 and x plus 4. Over here, we would say something like the factors are 2, 3, x, and x. Now we have 3 and x plus 4, and so the x plus 4 is itself a factor. There are two things being multiplied, the 3 and the x plus 4 are the two things that were being multiplied, and the kind of multiplication was distribution. So that brings out this key idea is being good at the multiplying will help you master factoring. And that is where we might run into some problems, because you need to be very good at distribution, and later I would say you'd have to be very good at foiling or multiplying binomials together. And what happens too often is you're not really given enough time to get good at the multiplying before somebody starts to throw the factoring at you. It's kind of like making sure that you can crawl before you can walk, or that you can walk forwards before you can walk backwards. The better you are at doing this, the easier it's going to be to master the factoring. All right, let's talk about the GCF. GCF stands for greatest common factor, and students will very frequently get this confused with the least common multiple. So when we were doing systems of equations and you have to find like what do you have to multiply by, what you're really looking for is the least common multiple, and students will often tell me greatest common factor. And again, that probably kind of comes back to not really chewing on it enough. I know the other day in class I was using the word digest, let your brain digest this. So I don't know what it is with me and like eating and digesting. That's the metaphor I'm going with here. But like that, you kind of need to chew on a concept and do a lot of problems and get very comfortable with it so that like the idea is solid. The definition of the greatest common factor is the largest factor that two or more expressions have in common. And that should make some sense to you. Common. Okay, so you have greatest, that's the largest factor here, that two or more expressions have in common. So what you would do is you would look at your two expressions and you would look at all of the factors, and then you try to figure out what's the biggest factor that they have, that they share together. So the easiest way to illustrate this is with numbers. Okay, but we're obviously going to expand this to variables. In fact, a lot of students will find the variable part easier once you kind of get the rhythm of it. So we're going to look at the numbers 18 and the number 24. And what I'm going to do is I'm going to list the factors in pairs. Okay, and this will become a useful skill when we start factoring trinomials. So to get 18, I could do 1 times 18, I could do 2 times 9, or I could do 3 times 6. So the factors are 1, 2, 3, 6, 9, and 18. So for those of you that are writing this down, okay, I know sometimes I write a little fast. So I took the 18 and I broke it down into its factors. I just kind of broke it down into the factor pairs. 1, 2, 3, 6, 8, 9, and 18. Now I'm going to do the same thing with the 24. I could have 1 times 24, 2 times 12, 3 times 8, and 4 times 6. Now, the better you learned your times tables, the easier that's going to be. So if you had an elementary school teacher or a middle school teacher that drilled you, I have a cat that's like turned himself inside out, that drilled you in your times tables, go find their email and go send them a thank you note, okay, through email. thanking them for drilling your times tables because now it's going to come in handy. The factors for this, for 24, are 1, 2, 3, 4, 6, 8, 12, and 24. So now we have the list of factors for 18 and we have the list of factors for 24. The common factors are the factors that they share with each other. So they share a 1. Both of them have a factor of 1. 1 is always a common factor, just so you know. They have a common factor of 2. They have a common factor of 3. Let's see, they have a common factor of 6. And not 9 and not 18. So when you look at the list of common factors, the greatest common factor would be 6. And what probably should have happened at some point in elementary school when you were learning times tables, like probably past where you learned your times tables and your division and stuff, but before you got to algebra, it would have been good if you had done a lot of examples like that, where you just had to find the greatest common factor. All right, so what we're going to do next is an activity. Normally, I actually go out and I buy a mountain of candy and it's like covering my living room and I sort it into all kinds of baggies and it's like my favorite algebra lesson of the year. Can't do that during COVID and we can't do it virtually anyway. So we're going to do a digital version of it and we're going to transition over to live class and I'm going to show you how that activity works.